In this problem, we're going to look at relationship satisfaction with one supervisor, which is a big predictor of job satisfaction and organizational commitment. Now, from the data that we've collected, we've got some information about APU org psych students and their satisfaction with their boss. And so here we've got the data here. And suppose that we know that the population mean, that means everybody in the world, is the average is about 3.50 with a standard deviation of 0.7. What we want to do is we want to test the hypothesis that org psych students are more satisfied with their boss than typical, than average, than the rest of the world. And the reason why we might suspect that this is true is because Azusa Pacific's a pretty relational place, and as a Christian university, we put an emphasis on being kind and loving to each other, and hopefully that plays out in the way that we work with each other. And since there's an awful lot of people at work at APU in the org psych program, maybe that will boost up the average to some degree. Okay, so we're comparing this data with the population. So that means we're going to use a z-test. So I'm going to go over to the z-test calculator, and I'm going to copy this whole section here, and Control-C for copy. I'm going to go back to tab 12.xx, and I'm just going to paste it over here, Control-V for paste. And now we have the z-test calculator where we have to enter the data, we have to change the population mean and the population standard deviation. So the data, let me copy it here. I'll do Shift Control down, and that'll get everything in the table. Control copy. I didn't calculate the header, so I'll put it up here on the top row, and then I'll do Control V. And there we've got the data. Now we have to adjust what the population mean. The average worker has a 3.5 average with their supervisor with a standard deviation of 0.7. So if I move that down now we've got our data. We've got n equals 25. That counted the number of participants we have. The x bar that we obtained from the sample is 3.92, so that's good because that's higher than the 3.5. That's what we were hoping for, but now we've got to find out, is that statistically significant? Is that more than we could expect by chance, given 25 students, or is it just something that seems normal and maybe the average really is 3.5? Well, the z obtained is 3, which is pretty high because 2 is around 2 is typically the cutoff, and we have p equals 0.001 for a one-tailed test. Now that's exactly what we were looking for because our hypothesis was org psych students are more satisfied with their boss than typical. So that that more than typical, that's a directional hypothesis. That means a one-tailed hypothesis. So that's the p-value that we're going to use. So how are we going to write this up? Let's do something like this. Our one-tailed hypothesis that org psych students have a higher quality relationship, I'll go down a line, with their supervisor then average is confirmed. Okay, so he's made a general statement saying that our hypothesis was confirmed. Now let's explain why we believe this. A one-tailed z-test, now z has to be in italics, turn italics off, z-test indicates that the average level of org psych students relationship quality with supervisor. Now we can put what that data is. We're going to have n equals 25, so n is in italics, control I, n, nope, capital N. Oops. Equals 25, and the mean, the capital M goes in italics too. Mean equals 3.92 is greater than, let's go to the next line, the population mean. And so this is what we had and were given. Control I, Shift M, Control I. For the population, the mean equals 3.50. The standard deviation, SD, Control I, SD, equals 0.70. And now we can give the z-statistic is greater, so the mean for our sample is greater than the mean population mean. Now we can add the statistics. I'm going to put this outside of the parentheses. Z, Control I, Z, Control I, equals, now we've got 3.00 is what we obtained, we calculated for Z obtained, so I'll put 3.00, and then P equals 0.001, Control I, P, Control I, space equals space 0.001, and this is a one-tailed test. So I'll put one-tailed. And there we've got a report on what we, our test that's in APA format.